Now we're going to work on the next key concept, which is percentile. Percentiles are measures of location denoted 1 all the way through P99, which divide a set of data into 100 groups, with about 1% of the data in each group. For any set of n measured in ascending or descending order, the pth percentile is a number such that p% of the measurement fall below the number and 100 minus p% fall above. When I think of percent, I think of the part over the whole. For example, here we're talking about data which is divided into 100 groups. The whole is always 100. For example, I pay 6% tax on $100. The whole is 100, which I have there in my denominator. And the part is 6. We can say that 6 over 100 is the same as 6%. And if you put that into your calculator, you'll get 0.06. Also, if you start with 6% and you're dividing by 100, every time you move your decimal place, 1 decimal place, you're dividing by 10. So that's divided by 10, that's divided by 100, and where I don't have a number, I put a 0. If I want to find the percentile of a data value, the process of finding the percentile that corresponds to a particular data value x, so x is just the number we're talking about, is given by the following rounded to the nearest whole number. Here, 6% is equal to this decimal. This is equal to 6%. And these, since they're equal, when we do any math, we always do math on the decimal. Let's say I have 100 values and 7 of them are less than 10. This is the part over the whole. What if I have 15 pieces of data and I want 4 of them? This is the part we want. And here, this is what we have. This would give me the decimal amount. When I multiply by 100, this part makes the decimal into a percent. And the same thing would be true here. So if I multiply by 100, this part makes it into a percent. 7 over 100 is 0.07. If I multiply that by 100, I get my 7%. 4 divided by 15, and that equals 0.266. It just repeats. Some of you will have at the very end of your numbers a 7 because they're rounding up. The Airport Verizon cell phone data speed listed below are arranged in increasing order. Find the percentile for the data speed of 11.8 megabits per second. So I look here and I find right here, there's my 11.8. And I want to know my percentile, the part over the whole, and then I'm going to multiply that by 100 to get it into percent. What it means is the number of values, n, is less than 11.8. When we find those numbers, that becomes our part. Let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers per row, and I have 2 rows of numbers. That gives me 20 numbers that are less than 11.8. My percentile is equal the part, which is 20, divided by, if each row has 10 and I have 5 rows, the whole is 50. I multiply that by 100. I get 40%. The percentile for the data speed of 11.8 is 40%. I don't count that number because I'm looking for numbers less than 11.8. Finding a percentile. Interpretation. A data speed of 11.8 megabits per second is in the 40th percentile. If I have 11.8 megabits per second, and I know it's in the 40th percentile, what it means is that 40% of my data is below that number, and 100 minus 40%, which is 60%, fall above it. That number is what's separating the lowest 40% from the highest 60%. When we see an N, it means the total number of values in the data set. K is going to represent the percentile. L gives the position of the value. For example, if I had a list that was sorted, I start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. L is giving me the 12th position. And P sub K, well, we already talked about K up here, where K is the percentile. P sub 25, it means I want the 25 percentile, which means I want 25% of the numbers in the data set to be below whatever the number is in the 25 percentile. We have here a flow chart. I'm going to do it with this example, same exact numbers as we had before. The first thing says start. Okay, we're ready. Sort the data and arrange the data in order of lowest to highest. It's already done. And again, this is just for the sake of you understanding what you're doing, because in StatCrunch, you just get these numbers, not that you have to find them, but that you're understanding what information you're receiving. Now we have L. If I want a certain percentile and I divide it by 100, and then I multiply by however many numbers I have in the data set, I should get the position of that percentile. We have L. K is equal to 40. We divide by 100, and we multiply by the number of values. And remember, we said there's 5 rows of 10, which gives me 50 values. And you can take a calculator out, but I can cancel those zeros. 5 over 10 is the same as 1 over 2. So this is the same as 40 times 1 over 2, which is 20. Now I'm here. If L is a whole number, well, L is a whole number. It's 20. It's not 20.5. It's not 20.1. It's a whole number. If it's a whole number, I do whatever is in this green box. Let's do what it says here. The value of the kth percent But we're talking about the value of 40% is midway between the L. We said L is 20. This is 10. 20 would be this value here, 11.6. It's midway between 11.6 and the next value. The next value is 11.8. It's midway between 11.6 and 11.8. How do I find the midpoint of those two values? It's the same as finding the average or the mean. I add them together and I divide by the number of numbers that I have, which is exactly what this says. It says find P sub k by adding the L value, which is 11.6, and the next value, which is 11.8, and dividing the total by 2. My value that I'm looking for is 11.7. They're just basically saying it's some halfway between the 20th and the 21st. They add those two numbers together, divide by 2, they get 11.7, which is exactly what we got. I want to find what's in the 41st percentile. So this would be P sub 41. Well, I would have 41 divided by 100 times 50 is actually 41 over 2, which is 20.5. Now it says, is L, and is this a whole number? No, it's not. Change L by rounding it up. We're rounding it up no matter what, to the next larger whole number. I'm taking my 20.5, and since I'm rounding up, I'm making it 21. The value of P of 41 is the Lth value, and L is 21. If I wanted 41%, it would be 11.8. Now I want to show you a couple of examples using StatCrunch. First example, use the following cell phone airport data speeds in megabits per second for a particular network. Find the percentile corresponding to the data speed 7.5 megabits per second. I'm going to click on this box. I'm going to open this in StatCrunch. Then I'm going to go to data, percentile rank, and I'm going to pick my column of var1, and I hit compute. It's just saying the new column percentile rank of var1, which is right here, has been added to the table. And now I just look for 7.5 over here on var1. And here's 7.5. And right here is the percentile rank. The answer is 74. I type in 74 here, check answer. That's it. In StatCrunch, it's really that easy to find, but it is nice to know what you're finding. Use the following cell phone airport data speeds in megabits per second from a particular network. Find P of 90. If you remember, this means the probability that 90% of all values are below that. I'm going to click on this box, open in StatCrunch. Now I'm going to go to Stat, Summary Stats, Columns. I'm going to pick var1, and the only other thing I need is right here. It says percentiles, and it says optional. Enter 30 or 30th. We're going to just type in 90 and compute. And I get 12.15. Do not round. 12.15. And I check my answer, and that's really all. Now you understand what data you're getting back if you watch the video, but that's how simple it is to actually do the question.